Hello, biology students. It's Mr. Johnson here. We are going to be finishing out our year learning about evolution. But before we do, we want to take just a brief amount of time and discuss the Earth, how it formed, how it changes, and a little bit of the history of life on Earth. So to start us off with, we are going to be taking a few notes. It's not a bad idea to either find a place in a notebook or maybe a tab on your Chromebook where you can take notes. You're always welcome to stop this video, rewatch it if you need to, and watch it again if you want to. So again, the goal of today is to give you a brief history of how the solar system and the Earth formed so that we can understand how it changes, so that we can ultimately understand how those changes affect the life on Earth. Because this is, after all, biology, the study of life. So let's get into it here. Let's learn about how the Earth formed. This is a brief dip into Earth science. Let's go back, way back, all the way back to the solar system and how it formed. Now, if you're interested in what we're about to go through, I do teach a whole class where 1/4 of it has to do with astronomy. So you can consider taking that if this is interesting to you. Okay, to begin with, our solar system formed the way other solar systems form. There are many other ones. The Earth and all of the other parts of that solar system formed around the same time period. I'm not saying it formed at the exact same time because at this point we're talking about what's called, it's deep time. It's really mind-blowingly large amounts of time. And so I can't say it formed on the same day or in the same minute. That doesn't make any sense. It's around the same time period. So how did it happen? Well, stars, including our own sun, forms from a cloud of gas that we call a nebula. A cloud of gas condenses. And as it condenses, it tends to sort of form a disk that spins and rotates. And what happens is that spinning disk will continue to spin, and the dust and space debris that is moving around that center will form planets. And as you might guess, that center ultimately forms the star. And so that's kind of what we're talking about here. That gives you a really brief introduction to how our solar system formed. A big cloud of gas and dust in the space condensed down to form a star. As it did that, a spinning, rotating disk moved around it, and then eventually all of that gas and dust, or most of it, sort of clumped together to form our different planets. And this is happening all over not only our galaxy, but the universe. So let's discuss our planet. The formation of the Earth and the solar system is about 4.6 billion years old. We could write that with a bunch of zeros, but we're not going to right now. And as I just mentioned, the Earth and the rest of the solar system formed at the same time or around the same time period. Now, there's a lot of evidence to support this. We can look at rocks. We can look at not only rocks that we have on Earth, but we can look at it and compare it to meteors, and they turn out to be the same age. We can also compare those to the rocks that were gathered from the moon, and that gives us other evidence as well. There's all sorts of evidence in the solar system that we're not going to dive into right now, but the basic idea is that it's out there. There's a lot of supporting evidence for that 4.6 billion years old of the Earth forming along with the rest of the solar system. So how did the Earth actually form? Well, as I just told you, we have all of this space debris, sort of these rocky bodies, this gas and dust and stuff that's sort of orbiting the sun. And anything with mass, anything with, any object made of material has gravitational pull. In other words, the larger something is, the more gravity it has, excuse me. For example, I have gravity, but I'm not very big. And so the Earth, which is much larger, its gravity has more of an effect on me, which is keeping me close to the Earth. Okay, so what basically the idea is that we have all of this material orbiting the sun, and we sort of get a snowballing effect where some objects sort of clump together, and that gives us a slightly larger object, and that slightly larger object then has more gravity, so it tends to pull in things smaller than itself, and so we get this bigger and bigger and bigger growing ball. And you know, the larger that these objects get, the more that they will grab hold of, you know, gravitationally pull objects around it. And so we get this larger and larger object that eventually forms a planet. Well, the interesting thing is this is how all of our planets formed. So what happens is over time, the Earth it ended up heating up, because anytime that there's two things that hit each other, they become warm. Also, so you can imagine all of these impacts from asteroids and all sorts of things in space hitting the early kind of forming Earth. And then there's all sorts of other interesting things happening too. You know, there's radioactivity. And anyway, so the Earth more or less melts. And when it melts, what happens is things that are dense, more dense, heavier is kind of a way of thinking about it, they sunk to the middle. And the things that were lighter, the material that was lighter, kind of floated toward the top. Now, what this did is this set our Earth into having layers. In the very center of the Earth, there's an iron core that's really, really dense and really, really hot, but it's solid. Just outside of that, it's really, really dense and really, really hot, but not quite as hot, so it's a little bit of liquid. And then outside of that, it's a little bit less dense, and that's sort of molten rock. And then outside of that is sort of this cooled rock. Now what happened is the magma eventually cooled on the surface. So we had this molten planet that separated into layers, and the surface started to cool down. And that cooling process is kind of like the surface of soup that you let sit out too long. You know, if you have a nice, I don't know, tomato soup or something like that, if you leave it sitting out for too long, it gets that kind of that gross film across the top. Well, that's sort of the surface of the Earth. The whole thing was melted. It was all liquid. And basically the parts that were in contact with space, which is really cold, ended up cooling, but there's still movement underneath, which causes all sorts of things to form, like mountains and, you know, valleys and even earthquakes. So you can see all of these impacts on Earth in this video that you're seeing on the screen. Now what happens is, just like your soup that cools and gets kind of that gross film on the top, you can imagine if you were to take and somehow stir the soup underneath that film, you can imagine if you kind of cause the soup underneath to move around, that the skin or the film on top would bunch together in certain places and maybe separate at other places. And that movement and separation and all of that kind of stuff, that's how our plates move. That's how these things called, you know, plates of the crust move. And the movement of those, when they hit each other, they form mountains. When they move away from each other, when two plates move away from each other, they form valleys. And when two plates kind of move past each other in opposite directions in some way, it causes an earthquake. And so that's the basic idea of how plate tectonics happen. And I believe you may have learned that in world geography at some point. And so I'm not going to dive into that too much. But think about this. Without that plate movement, we wouldn't have mountains, and we wouldn't have valleys, and we wouldn't have oceans the way we know them. We would have, the world would be a much different place. And remember, anytime that we have a change on the Earth's surface, it will affect the life on that surface. Now, this is where I'm going to sort of move quickly. How things formed. Ultimately, I want you to be able to work on a web quest today. How did the ocean form? Well, we had all these meteorites that hit the Earth, and when they did that, they brought tiny little microscopic amounts of water to the Earth, and so we have this big ball of kind of melted Earth, and when you heat up water, it becomes water vapor, and that moves away from. It's very light, and so it kind of quote unquote sort of floats to the surface in what would be soon what would soon be our atmosphere. And what happened is, as the crust cooled and as the steam cooled, what happened is we had these kind of pools of water that would form, and that led to oceans. Our atmosphere formed from this sort of chemical soup that was going on at the time too. So we had all of this sort of chemical reactions happening. The Earth was spewing gases into the air, and in the early Earth formation, it was pretty nasty. Like the atmosphere, if we were to snap our fingers and go back then, we wouldn't be able to survive. Nitrogen, carbon dioxide, methane, ammonia. You'll notice one of the things that's not on there is oxygen, the very thing that you and I need to breathe to stay alive. And we'll discuss where that came from a little bit later. The basic idea, though, is that we had this, and by we I mean the Earth, had the first prokaryotes, the first bacteria show up sort of in the oceans because that's where it's the most gentle. It's the easiest to live in the oceans if you can. What I'm going to do is I'm going to stop here, and I'm going to let you work on a web quest. The web quest is about geologic time. It sort of works your way through, it helps you work your way through essentially everything from here on out. Now, obviously, a lot's happened during that time, for the last 4.5 billion years, 4.6 billion years ago. That's a lot of time to cover. And we're just going to really skim over the surface of it. So at this point, you can stop taking notes. You can go and work on that web quest. Let me know if you have any questions on the way, and good luck.